Put your hand on a table. Feels solid, right? Now press harder. It still feels like your hand is touching the table. But according to physics, something very strange is happening. Your hand never actually touches it, not even for a moment. In fact, you've never truly touched anything in your entire life. Not your phone, not your keyboard, not another person, nothing. That sounds ridiculous, but it's exactly what modern physics tells us. To understand why, imagine shrinking yourself down, smaller, smaller, past grains of dust, past cells, past molecules, until you're standing among atoms. At this scale, things start looking very different. Atoms aren't little solid balls like they're often shown in textbooks. They're mostly empty space. If an atom were the size of a football stadium, its nucleus would be about the size of a pea sitting at the center. Everything else would be empty, which means that both your hand and the table are mostly empty space. So why don't your atoms pass straight through the table's atoms? The answer is electricity. Every atom contains negatively charged electrons, and electrons really don't like being pushed into other electrons. When the atoms in your hand get close to the atoms in the table, their electrons begin strongly repelling one another. A force appears between them, and that force becomes incredibly powerful at extremely short distances. It's similar to trying to push the same poles of two magnets together. Take two magnets and put north against north. Feel that invisible resistance? Now imagine a version of that force billions of times stronger at tiny distances. That's essentially what's stopping your hand from passing through the table. You're not touching the table, you're being pushed away from it. Every sensation you call touch is actually electromagnetic repulsion. Right now, countless electrons in your skin are pushing against countless electrons in the table. Your brain interprets that force as physical contact, but no atom from your hand is actually merging with an atom from the table. There's always a tiny gap, an unbelievably small gap, but a gap nonetheless. And it gets even stranger. When you sit in a chair, you're not truly sitting on it. You're hovering above it by an incredibly tiny distance. When you walk on the ground, you're not really touching the ground. You're being supported by electromagnetic forces between atoms. Even when a hammer hits a nail, the atoms never truly collide like billiard balls. The forces between them do all the work. Reality isn't made of solid objects smashing into each other. It's made of fields and forces interacting. In fact, most of what we experience as everyday life is really the electromagnetic force doing its job. Without it, matter would behave completely differently. Your hand could pass through walls, chairs couldn't support you, objects couldn't maintain their shape. The world would become unrecognizable. So why does everything feel solid? Because the repulsive force becomes enormously strong before atoms can overlap. Your brain can't tell the difference between touching and being prevented from touching. To your senses, they feel identical. But at the atomic level, they're completely different. Think about standing outside a building surrounded by an invisible force field. You walk toward the wall, and suddenly the force field stops you. You never actually reach the wall itself, yet from your perspective, it feels like you've hit something solid. That's essentially what happens every time you touch anything. The wall isn't stopping you, the atoms are. And the atoms aren't even doing that directly. Their electric fields are. What's fascinating is that this means the solid world around us is not as solid as it seems. The chair you're sitting on, the screen you're looking at, the floor beneath your feet, all of them are mostly empty space held together by invisible forces. The reason reality feels solid isn't because matter is packed tightly together. It's because the forces between atoms are unbelievably strong. So the next time you put your hand on a table, remember something strange. It feels like contact. It feels like touch. It feels completely normal. But deep down, at the atomic level, your hand never actually reaches the table. Instead, billions upon billions of tiny electric forces push back just enough to convince your brain that touching has occurred. And somehow, that invisible interaction creates the solid world you've known your entire life.